Hello, welcome to Zigmatech Learning Hub. I will be your instructor for mathematics. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GC, KCPE, IJMB, JUPEB, BECE, SSCE, NCEE, and NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class, okay? Let's get started. Okay, welcome once again. So today's class, our topic is matrices and determinant. We have been talking about matrices. This time around, determinant is involved, but let us look at what we are expected to know from our specific objectives. By the end of this lesson, you are expected to work out the adjoint of a matrix. Solve determinant of 2 by 2 matrices, that is 2 order or second order matrix. Provide solution for determinants of 3 by 3, then determine the inverse of a given matrix. But the inverse should be limited to what? Just 2 by 2. Adjoint of a matrix. The adjoint of a matrix mathematically is represented as ADJ adjoint. ADJ equals what? Transpose of a cofactor. That is, adjoint equals what? The transpose of a cofactor. Then, remember from our last class or in the previous class, we have learned the cofactor, the minor. Now we are dealing with adjoint. Find the adjoint of the matrix. It means before you think about the adjoint of any given matrix, you must go through 1, minus of the matrix, 2, the cofactor of the matrix, then transpose of the matrix. How many reverse are you going to cross? 3 reverse. Will give you solution to what? Adjoint of a given matrix. Now, if matrix A equals, this is 3 minus 1, 4, 2, 1, 5, 1, 2, 1, 2, 3, we think of minus of A. Minus of A will give us A11, A12, A13. So A11 equals this way, that is 1, 2, 5, 3. To give us 1 times 3 minus 2 times 5. To give us 3 minus 10 equals who? Minus 7. A11 equals minus 7. Then A12 will give us this way, 2, 1, 5, 3. 2 times 3 minus 1 times 5. 6 minus 5 equals 1. A12 equals 1. Then A13 equals this way, 2, 1, 1, 2. 2 times 2 equals 2 times 2 minus 1 times 1. They give us 4 minus 1 equals 3. A13 equals 3. We are done with that. Now, next to consider is A21. considering A21. A21 equals, that is here, A21. This way, all remain, minus 1, 2, 4, 3. That is minus 1 times 3 minus 2 times 4 equals minus 3 minus 8 equals minus 11. A21 equals minus 11. Then A22 equals A22 this way, that is 3, 1, 4, 3, to give us 3 times 3, minus 4, 1 times 4, to give us 9 minus 4 equals 5. A22 equals 5. Then A23 equals this way, 3 minus 1, 1, 2, 3 times 2 minus bracket 1 times minus 1, that is 6 plus 1 equals 7. A23 equals 7. Then the next is A31. A31 equals this place, A31. Go like this, you go like this, meaning minus 1, 1, 4, 5. To give us minus 1 times 5 minus 1 times 4. Minus 5 minus 4 equals minus 9. A31 equals minus 9. A32 equals A32 here. This way. That is 3, 2, 4, 5. 3 times 5 minus 2 times 4. 15 minus 8 equals 7. A32 equals 7. Then A33 equals this way now. Go like this. That is 3, 2, minus 1, 2. Minus 1, 1. 3 times 1 minus brackets 2 times minus 1. This is 3 plus 2 equals 5. So A33 equals 5. Okay, arrangement of our solutions. That is A11, A12, A13, A21, A22, A23, A31, A32, A33 equals the minus of the matrix. Minus equals A11 minus 7, A12 1, A13 3, A21 minus 11, A22 5, A23 7, A31 minus 9, 7, and 5. So this is the minus of this matrix. What next? We'll have to think about the cofactor. Now the cofactors. Cofactors, recall plus, minus, plus, minus, plus, minus, plus, minus, plus, okay? Then the first solution is 7. Plus minus is still minus 7. Minus plus is minus 1. Plus plus is plus. Minus minus is plus. Plus plus plus. Minus plus minus. Plus minus minus. Minus plus minus. Plus plus plus. This is the cofactor. Then adjoint. Adjoint equals what? Transpose of who? Cofactor. Therefore, ADJ equals minus 7, minus 1, 3, 11, 5, minus 7, minus 9, minus 7, and 5. This is the adjoint of the matrix. That is the adjoint of the matrix. Okay. Determinant of 2 by 2, or second order determinant. Second order determinant. Determinant is represented with the symbol that A, or this. That or this symbol. Depending on the alphabet given to you. So given the matrix 7342, 7342, this is a matrix. If you want to call it determinant, I say that equals 7, 4, 3, 2. That is 7 times 2 minus 4 times 3. They give us 14 minus 12 equals 2. So the determinant is what? 2. So now, 3 by 3 matrix. We are done with the 2 by 2. Let us consider the 3 by 3 determinant of matrix. 3 by 3, there is a rule that will guide it. Given A11, A12, A13, A21, this time around, let me use capital letters. A21, A22, A23, A31, A32, A33. If this is a matrix, its determinant A11, A21, A31, A12, A22, A32, A13, A23, A33, plus, minus, plus. Unlike cofactor and minus, where you introduce to every element, in determinant, you are not introducing these signs to all the elements. So what you are going to do here now, let's take one example. Find the determinant of this matrix. That is 3, 4, 6, 2, 1, minus 1, minus 4, 3, 5. This is a matrix. The determinant 3, 4, 6, 2, 1, minus 1, minus 4, 3, 5, plus, minus, plus. So if you are solving for A11, which will imply this, the first number you must consider it, that is plus 3. Then you cancel out to give us 1, 3, minus 1, 5. Then plus the second number, which is minus 4, into, you roll it, 2, minus 4, minus 1, 5. Then plus the last number, which is 6, into this, 2, 1, minus 4, 3. This will give us determinant equals 3 into this times this, 5 plus 3, minus 4 into 10 minus 4, plus 6 into 8 plus 4. That's 6 plus 4. This will give us 3 into 8 minus 4 into 6 plus 6 into 10 to give us 24 minus 24 plus 60 equals 60. So the determinant is what? 60. That's 3 by 3 determinant. You don't solve it like the minors or the cofactors. where you determine each element. No. Here, a single value is required. Inverse of a given matrix. That is just the second order is what is needed here. You don't need the third order for inverse in your mass, but in further mass is necessary. Now, what is an inverse of a matrix? The inverse of a given matrix is defined mathematically as what? Adjoint all over determinant. That is, if I have a matrix this way, mathematically speaking, inverse equals adjoint all over who? Determinant. Okay? But provided you are dealing with 2 by 2, we are not dealing with 3 by 3, we don't need this formula, okay? Look at one thing you need for inverse. Given a matrix A equals, let's say, A, B, C, D. First of all, to get the inverse of this, get determinant of A. What is determinant of A? Determinant of A implies AD minus BC. What next? Changing of position for the matrix given. That is, if matrix A is given to you, changing of position, that is, the position of A becomes D, while the position of D becomes A. Why B? Introduction of minus, C, introduction of minus. So that inverse, that is A inverse, the symbol for inverse is A raised to power minus 1 equals this D minus C minus B A divided by what? 1 over AD minus BC, which is determinant. Adjoint all over determinant. So let us take one question. Find the inverse of this. Let's solve this question. The matrix is 7, 3, 4, and minus 1. There's no any cause for alarm here. The inverse, let's say A inverse equals changing of position, minus 1 taking the position of 7, 7 taking the position of minus 1. Then 3 attaching with minus sign. So change of position first. I'm not talking of motion, so you won't think that we are dealing with motion now. That change of position of body depending on time. In physics, that's not what we are talking about. Yeah, just ordinary change of position. So get determinant of the matrix delta A equals to 7 times minus 1 minus 4 times 3 to give us what? This minus 7 minus 12 equals to minus 19. So inverse A equals change of position times the determinant, that's 1 over minus 19, into change in position minus 1, minus 4, minus 3, and 7. That is the inverse of the matrix. Now, we're going to take more questions from past question. UTME using the ExamGuide app. Okay, let's use this. A matrix P has an inverse of P1, P power 1, that is, a matrix P equals, that is the inverse of the matrix P1, and P raised to power minus 1 equals 1, 0, minus 3, and 1. Now the question is, Find the original matrix P. Inverse has been given to us. Now find the original matrix P. Remember, if you have original matrix, the inverse of it is the original matrix. Let's say XY, PQ. If this is the matrix, its inverse, change of position, Q, and X, then also attaching minus sign. If this is an inverse, now to get the original matrix from here, is still change of the position. Let's change the position. I'm divided by the determinant, meaning to get original P now is this coming here, X, and here. Attach minus, which is Y. Attach minus, this is P. Can you see it? The original matrix. Now let us consider this, which is an inverse, 1 minus 3, 0, 1. To switch to original matrix equals change of position. 1 is still taking position of 1. Now introduce minus minus here is 3. Here is 0. Okay. What about the determinant? Delta P equals C original matrix. 1 times 1 minus 0 times 3 equals 1 minus 0, which is 1. Now, inverse, recall, is what? The change of position. The change of position, 1 minus 3, 0, 1, which is descent divided by 1. So nothing much you are solving here. Change of position, addition or introduction of the signs. So if this is an inverse, original matrix will be what? 1, 3, 0, 1. So this is the original matrix. And that's the question they gave to you in JAMB to solve the original matrix. Okay. There's a determinant question. If P is find the determinant of P. Given that P is this matrix 1, 3, 2. The symbol they didn't type it well anyway. Minus 1, minus 3, 2, and 0 is supposed to be this. This is a symbol of matrix. Now the determinant, delta P or delta P, this is it, equals this plus minus plus. The first number is plus 1, which is this, into this 5, 2, minus 1, 0, plus minus 3 into this way, 4 minus 3 minus 1, 0, plus 2 into this way, 4, 5 minus 3, 2. This will give us 1 into 0 plus 2 minus 3 into 0 minus 3 plus 2 into this and this is 8 minus this, which is plus 15. Solution now is 1 into 2 minus 3 into minus 3, 2 into 23, to give us 2 plus 9 plus 46. So 2 plus 46 is 48 plus 9 to give us, carry 2 here, this is 50, 57. So the determinant is what? 57. So 57 is the answer. One more question here, then we'll think of the next topic. If P equals the matrix given here, find the value of P squared minus 2P plus 4 identity matrix. I have P to be equal to 1, 1, 2, 1, not 1, 1, 2, 1, minus 3 and 0. So we're told to find P squared minus 2P plus 4I. That is identity matrix. What is your P? This is 2, 1 minus 3, 0. All square minus 2 into P, 2, 1 minus 3, 0, plus 4 identity matrix. What is identity matrix? 1, 0, 0, 1. I've told you this from part 1 of our matrix. So this will give us 2, 1 minus 3, 0, dot 2, 1 minus 3, 0, minus bracket 2 times 2 is 4, 2, okay, minus 2 times 2, minus 4, minus 2, 6, 0. Keep this minus sign separate. Just be seeing these two. This 4, 2, minus 6, then 0. Now, if you want to recall, you can now introduce it. This is 4, this is 0, 0, 4, okay? I don't need to be teaching multiplication of again because we have taken our time for multiplication. It is now assumed that you know the rows and multiplication, rows against column. 2 times 2 is 4 plus 1 times minus 3, which is minus 3. Then 2 times 1 is 2 plus 0. We are done with the upper side. Here now, minus 3 times 2 minus 6 plus 0. Here now, minus 3 plus 0. Four, 2 minus 6, 0. Plus 4, 0, 0, 4. This will give us, this is minus 7, minus 6, 2, minus 3. Minus 4, 2, minus 6, 0. Plus 4, 0, 0, 4. So what do you have now? Minus 7 minus 4 is what? Minus 11. 2 minus 2 is 0. Minus 6 minus this minus 6. Then minus 6. Minus 6 minus minus 6 will give us 0. Then minus 3 minus minus 0 will give us minus 3 into this. This is 4, 0, 0 and 4 to give us minus 4 plus this is minus 7, 0, 0, 1. So what do you have? We'll have minus 7, 0, 1. Okay. That is that for the determinant and the matrix given to us You take time to multiply. Okay, 4 plus minus 3 here is plus 1. Then, this is 1. Correct it here. 1 plus 4 will give us 5. 0 plus 0, 0. This is 0. Then 1. So the solution is what? 5, 0, and 0, 1 as the solution. And that will give us the final answer to what we have. You cross-check it. Why summarize? This is the identity matrix. And let us consider these two here. 1 minus this equals minus 3. Then 2 minus 2, 0. Minus is minus minus this 0. Then minus 3 minus this minus 3. Then add them together to the identity matrix, which is 4, 0, 0, 4. It will give us what? Minus 3 plus 4 is 1. Then 0. This is 0. Minus this plus this is this. So what kind of matrix is this? This is 2 by 2 identity matrix. 2 by 2 identity matrix. So that is the final answer, 1, 0, and 0, 1. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.